Hello, my name is Akash Gautam. I've been a software developer in GeekyAnts for about 2.5 years now. And today I'm going to talk about a topic I absolutely love, and that is 3D rendering with basically React 3 Fiber for the purpose of this video. But 3D rendering in general in websites, I absolutely love this topic because it doesn't have any sort of upper limit. Whatever you can imagine, you can achieve it in it, you can create in it. And that's the beauty of doing this sort of animation game thingies with the 3D. So yeah, let's start with the basics. What is 3D rendering? The basic introduction. So it's basically a process of converting 2D into 3D. Basically, we can't actually convert it, we make it look like 3D. As I mean, see, the monitor is basically a 2D screen. We can't actually make something 3D inside of a 2D object, right? But yes, to make it 3D, to feel like 3D, so it has a lot of its uses. Basically architecture, real estate, entertainment, and gaming. Games, we all know there are a lot of games that are really good in 3D, and some even 2D games incorporate some very basic parts of 3D, like having different layers of background, but the pair, like the prayer and everything else is in 2D itself. Product design, manufacturing, when we go to see some bike or car showcases on their websites, and we can rotate, we can zoom in, zoom out, we can see the dashboard, everything, even the engine model, everything, pipes, wiring, everything is there. So that all is possible because of the 3D rendering in websites only. And yeah, medical and scientific visualization, for example MRI scans, we can actually convert them into 3D and see the exact the flow inside the brain, or what actually happens, so that the doctor can diagnose it better, right? Now, but what do we use inside it? Okay, so this is a very basic flow chart of what actually happens behind the scenes. A lot more actually happens, but we'll not go into it today. It's just a basic intro. So basically what it has: application layer, your user code, okay, what we write, and then it gets converted into the Three.js core components. Then it gets connected to the WebGL API through JavaScript, and then goes to the graphics driver, the GPU, where it calculates a lot of things, lots and lots of things. And then eventually it sends back some information to the browser, and browser uses that information to calculate whatever it needs to calculate, and basically print out everything on the screen itself. So yeah, that's like the basic gist of what happens. A lot more happens inside your textures, color, lightning, blur, what sort of colors will look, the shadows, everything, like down to the pixels, how it will rotate, how it will affect the rest of the scene. A lot happens behind the scenes, so let's talk about that some other day. So yeah, that's basically an overview, the top layer of what happens. And yeah, so what is WebGL? WebGL basically allows the JavaScript library Three.js to connect to the GPU or the graphics driver in general. And why do we need the graphics driver? Because as it's a 3D environment completely, the browser itself is unable to make those changes or create those stylings, like how in CSS the browser can calculate everything. But in 3D, the browser by default is not able to do this. So to make it work in there, we use an element called canvas. So inside the canvas, everything can be painted, and it depends on the browser's calculation of styling, but not everything is up to the browser. So it's a very mixed feature where the GPU does some of it, and then the browser calculates depending on the data, and then shows everything on the screen itself. So that's basically why we need the WebGL. It basically connects our JavaScript code, our browser, to the graphics, the GPU part directly. So it can does like do those calculations. So yeah, that's basically its role also. Now let's go to what library we use, how we build on top of it. So Three.js is basically a very powerful JavaScript library, and you can create almost everything with it. It's built on top of JavaScript. What you can do with Three.js, you can directly do with JavaScript by writing your own sort of little interaction, how to connect to the WebGL and everything. But it basically it gives you a very standard set of rules and a very basic configuration, that it's like it shortens the code from about, let's say, 100 lines to about 10 to 20 lines. And that, I'm not even exaggerating, it could be even more efficient the more you understand it, right? So that's the beauty of it. It gives you a very nice configuration, a very nice way of writing things, that it just feels good, natural to do it. And you can create anything that you want with it, everything that is supposed to like that is part of the 3D scene as an overall. Your graph, your lighting, shading, animation, shadows, interaction, hover, click, events register, events propagation, your boundaries, your interaction with each other. Everything 3JS can do, everything that's required for a 3D library to do, it can do, and that's why it's become one of the most powerful libraries. For gaming, people still prefer some other, like we have Unity also, we have D3 also, there are lots more, but 3JS is still one of the best standard that is used throughout, like from my knowledge base, throughout the world for website, like for 3D development in websites. But we'll still not be using 3JS. As I just said, we'll be using React 3 Fiber that is built on top of 3JS, and that is a more compatible for React users. That why that is? So that is because in 3JS, it's basically an object-like structure. We get an object and dot function, dot key, dot something. So everything is connected, but it's more like an object-like structure, how JavaScript is. React, it's more of a component-like structure. So if you are familiar with React 3 Fiber will be a better approach for you. So as I just said, 3JS gives you a very nice config, a very good default set of values, and then builds on top of it. React 3 Fiber is built on top of 3JS. So to make it more user friendly, more component friendly. So let's say if you want to create a scene in let's say a very basic a box and a background, and the box is rotating and you click on it and the color changes. So it will take about 20 to 30 lines, give or take 5-10 lines. Okay. But if we were to write the same thing using React 3 Fiber, it will shorten the code to about 15 or 20 lines. Or if the code is more complex, it can even be shortened more, because we have hooks in React. We have a lots of things in React that React gives us by default. So instead of doing that in JavaScript, if you were to do it the React way, the code will even shorten a lot more. So that's also one of the advantages of using React 3 Fiber. It's a very declarative syntax. It's nice. It's also more optimized. Like it's built on top of 3JS, so it's optimized a little bit more. It also has a component-based architecture, and it's very easily integrated with the React ecosystem. So yeah, now let's just start with it. So these are just like some of the most basic stuff that we'll do. So before all of this, you have to do the npx create React app to get a basic React app working. Then install this library, import canvas. This is the canvas we were just talking about. We need this to get the 3D scenes working. Our 3D elements don't work outside of the canvas, as the browser doesn't understand the context of what that styling, what that means. So to make all of that working, we need the canvas element to be there. And yeah, we can add 3D objects. This is a box. This is a standard material. So basically, an object in 3D consists of 2-3 separate parts. Okay, the kind of material it is, right? And like what the outside looks like. Is it solid? Is it transparent, translucent? Is it those wire? If it's not solid, what kind of material it is? So mesh standard material, there's more materials. This not just one sort of material. So it goes on and on and on. So this is a very basic example. Box, we have given it some position and we have given it a color, right? Now canvas, box, use frame, canvas, box, I've just told you about. Use frame is basically so the smallest value that per time for that browser, for that system that you can do, use frame provides us along with the state and a variable. So we can make the animation very fluid, very smooth. So we don't have to make it manual. Here I've given this 0.01, but it could be smaller than this, it could be bigger than this, depending on the device itself. Let's say if it's a mobile or a website, so the difference could be huge. But to make it smooth in all of those, we use this instead of set timeout or interval or some one of the JavaScript inherent functions. So we use the hooks here provided by the React 3 Fiber. So it's even easier for us to do this because it does a lot of the work for us, and it gives us by communicating to the device directly. And yeah, so yeah, let's just start with it and I'll show you a live example. So I have a working example. I've created it already. So I'll just quickly show you the dependencies. So here we have the Three.js. We need this because this is a dependency for React 3 Fiber. We need this library, and I'll tell you the reason in a little bit. And we need the types 3. The reason for this is like you just to make it TypeScript compatible and nothing more. So let's just jump directly into it. Okay. So this is our basic. We have wrapped our whole app with the canvas because the whole app is in 3D. If you want to mix 3D and 2D, you can have the canvas outside of just that specific part of the element that you want. And now I'll quickly show you the code. Okay. So this is a very basic example. Some lines are commented out. I'll comment them in and just explain you one by one what it is, what it does. So you'll get a basic idea of the basic. So we have an orbit control. We have a box, right? What is box made of? This box is an element that we created. Okay. It takes some props and it has its own ref. We have box geometry. We have mesh standard material, right? So what is mesh? Mesh is basically a complete 3D object, and inside the children box geometry mesh standard material that we passed, this box geometry basically tells React 3 Fiber that this mesh 3D object needs to be a cuboid in shape. Okay. These arguments, this basically gives it height, width, and length. So let's say if I make it 6, it will change. Okay. And okay, you might also be wondering why its color is black when I've given it the color red. I'll also explain to you in a bit. Okay. Yeah, stay tuned. So this is basically it, and this gives it. We've given the positions here. It's being passed as a prop here, and we are putting it to the mesh. Okay. Now let's add another box, and I've given it a bit different positions. So it's here now. Okay. Now why is this color not showing? Because basically to see the color, we need to have some sort of light. So let's comment these 3 out and see. Voila, red and blue. Now why there are 3 different types of light? Let's comment each one out and we'll see. So this is the ambient light. Okay, if I zoom in a bit, it looks overall everywhere for the same, right? Now but if I do this, if I change to spotlight, spotlight is basically spotlight. It comes from a specific angle itself. Same for the point light. Point light is also a point light, but it's from a separate source. Okay. Yeah. So to make an object look good, we might need multiple points, points of light sources. So this is it. Some like, even though the color is the same along the, the outside of the box, it looks a bit different on some sides. And the reason is because of the lighting only. Now let's say I want to add some sort of functionality. Yeah, before going into functionality, we'll talk about the useFrame, setFrame. So this I also showed in the example useFrame, and this orbit controls we needed from here. If I remove this, then I will not be able to rotate it or click on it or zoom in, zoom out. I will also be not able to do this. So orbit control basically gives the user the control to do all of this. I can customize it in a way that the camera is pointed a certain way, like how in car games it does. So we can make it more easier and specific to our use case. But in this case, because I've not given any props, it's giving me the complete freedom. I can rotate in whichever axis I want. I can zoom in wherever I want. I can zoom out to how much I want. Okay. So that's it. Now you might see some states and some more things. So let's comment this in and see what it does. So I've basically these 2 events on pointer over and on pointer out. I am updating a hover state, and on the state I'm changing the color to green. The first box is red, the other box is blue. Let's try hovering over it. Green, green. Hover out, color changes to normal. So it's just one of the things you can, ways you can play with it. You can have like, you can click and drag and drop. For this, I've just, if it's clicked, the color will change. So click on it, like not the color, the scale. As you can see in line number 16, scale, it goes to 1.5. And if I click this, it goes again. If it's not clicked, it goes back down. And this useFrame hook, see, this delta is the value that is very device specific. Now, if I make it 0.01, it's slower. That means the delta speed in this is different. If I make it 0.1, it's faster. If I make it 1, it's very faster. Super fast. Super fast. It's so fast that it's looking slower. So that's 1. Let's make it 0.1. Now let's give it back to delta. Yeah. So this is the, the lowest most that we can, make it smoother. We can change the delta values to have it more according to our own use case. But this is pretty much it. And yeah, this was a good a basic example. Intensity, we have just given it some value, and we have given these cameras position. So yeah, that's about it. That's the basics of React 3, and hope you guys enjoyed it. And yeah, so implement 3D rendering, create a scene. We created a very empty scene by using the canvas element, add 3D objects. We did that. We added 2 boxes and apply materials and textures. We also added lightning. We gave both of them the solid texture and my standard materials. Thank you. We are done with this and hope you guys enjoyed it. If you have any more questions, please feel free to reach out. And yeah, bye bye.